graph each system of equations and describe them as consistent and independent, consistent and dependent, or inconsistent. So consistent means that you have a solution. So really, all I really care about is it independent? Is it dependent? Independent means one solution, one unique solution. Dependent means infinitely many solutions. Right, so consistent just means it has a solution, and then inconsistent, well, consistent means it has a solution. Inconsistent means it doesn't have a solution, so no solution. So that's all I really care about. So I just want to know, hey, is there one solution here? Is it infinitely many solutions because they're the same line, or is it no solution? So we're just going to graph these. 3x minus 4, so negative 4, slope of 3, up 3 over 1. Like that. Y equals negative 2x plus 11. So plus 11 up here, down 2 over 1. So like this. And these guys cross at one spot. So there's only one solution, so it's independent. And if you want, you can say plus consistent, but consistent just means there's a solution. So to me, it's independent is the important part. Okay, the next one, oh, these are not the proper form, so we gotta rewrite in proper form. Right, so we gotta get the y by itself here, so we're gonna subtract 3x from both sides. So y equals negative 3x plus 9. And over here, I'm going to get the y by itself, so I'm going to add y to both sides and add 1. Y equals x plus 1. Like that. So right, I like to add y to both sides and then add 1 to both sides. So I get x plus 1 on this side and 1 on that side. So now I can just graph it. Plus 9. Slope of negative 3, down 3 over 1. So to that effect. X plus 1, so plus 1x. And again, they cross that one spot. I thought they'd do one of each, I guess not. So these are independent. Unless I messed up somewhere, but I don't think I did. So it's like that. Next one, we get y by itself. So add 2x to both sides, so I get 5y equals 2x plus 10. Then you divide by 5. So I get y equals 2x over 5 plus 2. Since I have that, I'll just graph it right now. So 2, slope of 2 over 5, so up 2 over 5. So like this. And we're just going to do the next one. I have some space down here. I'm going to get the y by itself, so I'm going to subtract 4x. So I get negative 10y equals negative 4x minus 20 divided by negative 10. So I get y equals 4 over 10 is 2 over 5x plus 2. So I get the exact same graph. And when that happens, it's a dependent consistent, but dependent all I care about. So dependent, same, all real numbers. No matter what you plug in, it's gonna work. So there's independent, there's dependent. I'm surprised I didn't do a parallel one, but live and learn. So the next one, solve system equation by substitution. So we're using substitution here. Substitution works best when you can get a variable by itself. So like this first one here, the y is by itself, so we can just substitute all this in for the y right there. So it's something like this, negative 2x minus 3. And the y we know is y equals 6x minus 11. So I'm just going to plug that in for the y right there, sub it in. And then we just solve it by like normal. Distribute the negative, so I get negative 2x minus 18x plus 33 equals negative 7. Add like terms, negative 20x plus 33 equals negative 7. Right, then here we want to keep the variables on one side and all the numbers on the other side. So let's move over to 33. Subtract 33. So negative 20x equals negative 40. Then divide by negative 20. Two negatives make a positive, so I just get 2. And we're not done. I got to solve the system. So all I got to x. I go back here and plug in my y. You could technically plug into any one of the equations, but this one's the easiest. Y equals 6 times x minus 11. by far the easiest one to plug it into. So just plug in 2 for x, and you get 12 minus 11, y equals 1. To make this look nice. You get 1, which is equal to y. So our solution is 2, 1, right? X and y. So there we go. Next one's not as straightforward. Like I said, substitution, when I think substitution, I think, okay, there's a variable by itself. I'm going to substitute. Since I know what the variable is, plug it in. This one you could do substitution, but it's not as clear cut. So what you want to do is get a variable by itself. And the easiest one to do it when there's no number in front of it. So that x, I could isolate that guy. So it's going to be x equals 1 minus 3y. And then from there, we could do what we did before. We could plug this in for the x over here. So it looks like this. And then you plug that in. Then we distribute negative 3 plus 9y minus 3y equals negative 15. Negative 3 plus 6y is negative 15. Plus 3 plus 3. 6y equals negative 12. Divide by 6. Y equals negative 2. So again, I have the y sending my x. Plug into any of these you want. I would plug into this guy. This guy's the easiest to plug into. So I get 1 minus 6. Double negatives. Negative 3 times negative 2 is a positive 6. So I guess 1 plus 6 would be the correct answer then. So I get 7. That's an ugly 7. So you get negative 2. Oh, y is x is first. 7 and negative 2. So like that. Next, we're going to solve this by elimination, which is my favorite method. So elimination, you want to eliminate a couple of variables, right? So you have equation 1, equation 2. In this case, it's easy. You're just going to add them up. So when I add these up, 3x plus 1x is 4x. The y's cancel out. And then over here I get 8. So then just divide by 4. X equals 2. Much like before though, when you're not done, you have an x, you got to find the y. So you can plug back into any one of these. I'm going to do the bottom. I think the bottom one's the easiest. So I'm plugging x equals 2. So it's 2 minus y equals negative 1. Just got to solve for the y. Subtract 2. Negative y equals negative 3. Divide by negative 1. Y equals 3. So my answer is 2 and 3. I'm going to do the same thing over here. Now this is the exact same problem we just did. But now we're going to do it by, okay, it's similar to the problem we just did. I thought it's the exact same one, but it's not. Now we're just going to do it by elimination. So in this case, it's not as easy. I can't just add them up. If I add them up, I get 4, 3, and negative 5. Nothing cancels out, right? If I just added them, that's not good. Nothing canceled. That doesn't help me at all. So we have to do, give myself a little space here, is we got to make two things the same. So you can either make the x the same or the y is the same. In this case, I think it's easier to make the x the same. I just multiply the top by a negative 3, and then they'll cancel each other out. So that's what we're going to do. Multiply the whole top row by negative 3. So I get negative 3x minus 15y equals negative 9. We're going to keep the bottom row exactly the same. And I always want them to be different signs. When I add them up, they cancel out. So now I can add them up. These cancel out. I get negative 17y equals negative 17. Divide by negative 17. Y equals 1. Now when you're not done, you got to find out what the x is. So you just go back and plug into one of these. So I guess the top one's the easiest because it's the most basic. So I have this. I'm going to plug in 1 for y. So I get x plus 5 equals 3. Subtract 5. X equals negative 2. So my answer is negative 2 and 1. So that's elimination. So we did elimination, we did substitution, and we did graphing. So all three different methods to solve a system equations. So now you can do the method of our choice. So it's really up to you on these. I'm a big substitution fan. I'm trying to see if there's any, elimination fan. That's what I'm going to do the first two, I guess. The first two, I guess, are just elimination. Here again, you can multiply anything you want. I like to keep them different signs. So I'll multiply the bottom, since I'm going to do elimination, by negative 3. Because I want these to be different, I want these to be different signs. When they're the same signs, they don't cancel out. So I multiply by negative with different signs. So remember, you have to multiply the whole row. So it becomes positive 3x plus positive 3y equals negative 9. Top, I'll leave it alone. I add them up. This right here should be a negative 3. Super easy to make small mistakes like I almost did there. Right? Negative 3 times negative x is positive. Negative 3 times y is negative 3y. Really easy to make small mistakes. These cancel. These cancel. I just get 0 on this side. And over here I get negative 5. So when this happens, we have no variables. They all cancel out. It's either it's either dependent or inconsistent, right? So either all real numbers or no solution. This is not true. 0 does not equal negative 5. So it's no solution. As well as say inconsistent. It's no, either one's fine, but no solutions. But I'm just gonna go with that's easier, right? So there's no solution. 0 does not equal negative 5, so don't have to. If this was a true statement like negative 5 equals negative 5, then it'll be dependent or all real numbers. Next one, that's an easy one. These middle two cancel out. So I'm just gonna add down. I get 4a, cancel, but that's a 0. Remember, cancellation just means 0. Now this is still good. That there's a variable there. I can actually solve this. Divide by 4. A equals 0. That's a fine answer. There's nothing wrong with that. So now all I gotta do is plug it back into one of these. I'll do the top ones because it's there. Alright, so we have that, and now I know a equals 0. So just plug in 0 for a. I get 0 minus 5b equals negative 20. That's just like saying negative 5 equals negative 20. Divide by negative 5. B equals 4. So 0, 4. Or you just put a equals 0, b equals 4. Next one. Again, if I'm going to do elimination, I want things to cancel out. So in this case, there's no shortcut doing this. I guess it doesn't really matter what I do. You want to get rid of the y's or the x's? I'd do the y's. So in this case, I want them to be different signs. So I'll multiply the top by 5. Right, the LCD of 2 and 5 is 10, so let's multiply this by 5, multiply this by 2. But then it would be the same number but different signs. The whole goal. I'm multiply this by negative 2 because, again, I want them to be different signs. Right now they're the same sign. So I get, do this to everything, 15x minus 10y equals 10. Remember, multiply by negative 2, so that's going to change everything. Negative 10x plus 10y equals negative 20. Add down, cancel, negative 10, 5x, divided by 5, x equals negative 2. So I have my x equals negative 2, you plug back into one of these to find your y. Top one I think is the easiest. So I get negative 6 minus 2y equals 2. Add 6 to both sides, negative 2y equals 8. Divide by negative 2. Y equals negative 4. So negative 2, negative 4. Next one, again, same idea. We're gonna do. I prefer elimination. We're just gonna do elimination, but we can make our lives a little easier here. Notice how they're the top ones you can divide it by 2, and the bottom you can divide it by like 5 or negative 5. So you make your life a little easier if you just want to reduce it first. I'm gonna divide everything here by this 5. So I'm gonna get negative x minus 4y equals negative 3. And on top, if I divide everything by 2, I get x plus 4y equals 3. Alright, just do that so I can make it a little nicer. And then now, look at, when I add them up, they're going to cancel out. 0 equals 0. So again, that is a true statement, so it's all real numbers. Or if you want to say it's a dependent system. Next one, now look at this top one. It's not in proper, these are not in proper form. So I could either put it in the normal form, or I could try something like substitution. I think I'm going to try that because I haven't done substitution yet. So I'm going to try substitution here. I'm going to get the y by itself because see, it's y is all nice. I'm going to get that by itself. So I'm going to add y to this side. So I'm going to get y equals 2x plus 3. Alright, all I did was add the y over and kept everything else the same and rearranged a little bit, but there you go. And now, since I'm going to do substitution, because I got a y by itself, I'm going to sub this in for the y right there. So it's like this. And I'm going to sub this guy in. Now we're going to do simplify, so distribute this -7. So I get -3 minus 14x minus 21 equals 10x. Add like terms, -24 minus 14x equals 10x. We want to get the x on one side and the numbers on the other side, so let's add the 14x to both sides. Right, remember this equal sign you can't cross without doing that. These cancel, you get -24 equals 24x. Divide by 24. I get x equals -1. So there's my x, I just gotta find my y. But again, when you do substitution, that's one good thing, that plugging it into the easy part. Plug that in there. I get -2 plus 3, which is 1. So my answer is -1 and 1. So again, I did it by substitution. You could also just rearrange this to look like this in standard form, and then that way you could just solve it by the normal methods. Okay, over here, I'm gonna do elimination. Now for me, I think the y is gonna be easiest. I can multiply that bottom one by 3, and the y's will cancel out. So top, we're gonna get -4x plus 9y equals 9. We're gonna get 3. It's a 3. It's a bad 3. We're going to get 3x minus 9y equals -18. These cancel. Add down, you get -x equals -9. But again, it's very easy to make a small mistake. So that gets me -x. That gets me -9. Divided by -1. X equals 9. So x equals 9. I got to go back, plug into anything I want. I'll plug into the bottom one. I think the bottom was easiest. So 9 minus 3y equals -6. Minus 9 minus 9. -3y equals -15. Divided by -3. Y equals 5. So 9 and 5. And then one last one and we're done. At a park, there are 38 people playing tennis. Some are playing doubles and some are playing singles. There are 13 matches in progress. A doubles match requires 4 players. A single match requires 2 players. Write a two-system equation that represents the number of singles and double matches going on. So with this, there's always two things. There's kind of like a value and a total. So like what's the value of things going on and what's the total of things going on. So let's do the total first. So let's talk about what we're doing again. So right at a park, there are 30 people playing tennis. Some are playing doubles, some are playing singles. There are 13 matches in progress. But double matches requires 4 players, single match requires 2 players. So we're talking about the number of matches we're playing kind of, right? So we're playing doubles. Let's say doubles is X. We're playing singles. That's Y. So if I add the number of doubles matches plus the number of single matches, I get a total of 13 matches. So that's the total one. Double matches plus single matches equals total matches of 13. Now there's a value one. So when I play doubles, how many people play doubles? 4 players are required for doubles, so 4x. And when I play singles, it requires 2 players, so 2y. How many total people are there? 38. So those are my two equations. You have one for like just the total, what we're talking about, total matches. And we have for the one for the value. How do you get 38 people? Well, 4 of them have to play doubles, 2 of them have to play singles. And you get this. And then you just solve it like normal. So if I was solving this, I'll do elimination because it's me. I'll multiply the bottom by -2. Right? Because that would get rid of the y's. So I guess that looks like this. 4x plus 2y equals 38. -2x minus 2y equals -26. These cancel out. That gets me 2x. And that gets me 12. Divided by 2. X equals 6. Right, so that's my 6. And then how do I find the y? You plug into any equation you want. I'll plug in the bottom one. That looks a lot easier. Then subtract 6. Y equals 7. So we're going to have 6 doubles matches and 7 single matches. And that's the lesson worksheet.